Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acid-catalyzed hydrolysis of ester groups followed by decarboxylation and hydrolysis of an enol ether or tautomerization of an exocyclic alkene is equal to CH2 under acidic aqueous conditions with heat. Moving on to the next step. The starting material is a cyclohexane ring bearing 1, an exocyclic methylene is equal to CH2 at 1 carbon, 2, a co-2 ester at an adjacent carbon, 3, a ketone, C is equal to O at another ring carbon, and 4, a second eto to C ester at another ring carbon. Moving on to the next step. Under aqueous acid and heat, both ethyl ester groups, co-2 and eto to C, are hydrolyzed to carboxylic acids -2. And for the final step, both resulting carboxylic acid groups are beta-keto acids. One is beta to the ring ketone, the other is beta to the enol ketone system from the exocyclic methylene. Beta-keto acids readily undergo decarboxylation upon heating, losing CO2. The exocyclic methylene is equal to CH2 under acidic aqueous conditions also tautomerizes. The is equal to CH2 adjacent to the newly formed carboxylic acid, which is beta-keto, decarboxylates to give a methyl group or simply a CH2 that becomes part of the ring ketone system. After double hydrolysis and double decarboxylation, both ester-bearing carbons lose their CO groups as CO2. The exocyclic is equal to CH2 becomes a simple CH2 ring carbon and the two carbonyls remain. The net product is cyclohexane 1,4 dione, unsubstituted, where both ester carbons have been removed as CO2 and the ring retains only the two ketone functionalities. Option A retains one CO2 group, but heat with H3O plus causes full decarboxylation of beta-keto acids, so no ester should remain. Option C. A phenol-enol product would require aromatization, which is not consistent with simple hydrolysis decarboxylation of this substrate. Option D eliminated because option B is correct. Therefore, the correct answer is B. Therefore, the correct answer is option B.